And next part, dividing polynomials. And there's also some theorems in here we'll take a look at. First off, we have long division. And the way you want to handle it is just the same way you did in arithmetic. So you'll take this guy and put him inside your sort of division symbol. So it's this guy divided by this guy here. So you put the x plus 2 on the outside. And then there's two ways to think of it. You can think of what times x equals x cubed. If you don't like that, you can take x cubed and divide it by x, and that's going to go right here. Okay, so what times x is x cubed? Well, that's x squared. We should put that right there. So x squared times x is x cubed. Actually, you should put it right here, sorry. Should put the x squared right here, sorry. Anyways, x squared times x is x cubed, plus x squared times 2 is 2x squared. And then we subtract the entire expression. So x cubed minus x cubed is 0. 5x squared minus 2x squared is 3x squared. Bring down to 7x. Okay. And then it's the same game. What times x is 3x squared? So you say, okay, that's 3x. So you'll get 3x squared plus 6x, and then you subtract. The 3x squares cancel. 7x minus 6x is 1x, and then bring down the next 2. This next thing down here. And then what times x equals x? Well, 1. Okay, so 1 times x is x. 1 times 2 is 2. And you subtract these. This time we have a remainder of 0. So it's an even division. You just get x squared plus 3x plus 1 as your final simplified form, I guess. So this is all scratch work. This is the answer you want to see. Okay, let's look at another one. So this one's nice. It didn't have a remainder, but you know what happens when we have a remainder. And you kind of should know if you consider a numerical example. So if you recall back in your memory banks, maybe you have something like 3 divided by 7. Right? So to get this thing, you take 3 and divide it by maybe we should try something like 30 divided by 7, I'm sorry. So 30 divided by 7. So how many times does 7 go into 30? Well, 4 times for a 28. 30 minus 28 is 2. So you could rewrite 37ths as 4 and 2/7. Okay? And that's how we used to do it, but technically there's a little addition sign in there. So it's really supposed to be 4 plus 2/7. And the way you compose that is to go 4 here and then plus 2 all over 7. And that'll give you your final sort of answer. Okay, so let's look at 8, where we have a remainder. We have 4x squared minus 8x plus 6 divided by 2x minus 1. So again, you set it up just like you would in arithmetic. And you're asking yourself, what times 2x is 4x squared? So you go, okay, that's 2x. Then 2x times negative 1 is minus 2x. And subtract those guys, and you get negative 6x plus, bring on the next term. And then what times 2x is negative 6x? So minus 3. Okay, subtract those, so you get 6 minus 3 is 3 as your remainder. Okay, so for writing up your answer, and again, this is just scratch work down here. The answer is going here. Okay, so writing up your answer, you'll have this guy, the 2x minus 3. And then you'll make a fraction from the 3 and the 2x minus 1. Okay? So it'll be plus the 3 all over the 2x minus 1. Okay. The problems get more complicated if they're not in perfectly descending degree. So the degree of this is 2 and then 1 and then 0. Sometimes they'll skip. So maybe it'll be degree 5 and then 3 and then 1 and then 0. So in order to deal with those, we use placeholders in our setup. So section 2 using placeholders. And we have problem 11. So we got 4x to the 4th minus 4x squared plus 6x all divided by x minus 4. Okay. So when you set up your division, what you're going to do is put zeros in between the numbers. I mean, you do it all the time back in arithmetic. So in arithmetic, a number 304, this number 0 here is kind of like a placeholder. It tells you there's 0 tens. There's 3 hundreds, 0 tens, and 4 ones. Okay? And you know, sort of in polynomials, you don't do that. Right? You're not saying 4x to the 4th plus 0x cubed plus minus 4x squared plus 6x plus 0. You know, you don't do the same thing. But when you're doing division, it helps. It helps so you can line things up. So that's what we do. So you go 4x to the 4th plus 0x cubed minus 4x squared plus 6x. And if you wish, you could go plus 0 right there. And it's all set up for you. Okay. Right, so again, you go back to the idea, what times x is 4x to the 4th? So you get 4x cubed. So you get 4x cubed minus 16x, 4x to the 4th, sorry, minus 16x cubed. Subtract these. And so this minus this is 0. This minus negative this will become positive 16x cubed. Okay, so I need to bring down the next term as well. What times x is 16x cubed? So you say plus 16x squared. So 16x squared times x is 16x cubed, and then 16x squared times minus 4 is minus 64x squared. And then again, we got to subtract those. Okay, so this will be 0. This will be 60x squared, and bring down the next term, 6x. So you say, what times x is 60x squared? You'll say 60x. So you have 60x squared minus 240x. And then we'll need to subtract those. So this will be 0, and then here 246x. So things are getting a bit out of control, plus 0. What times x is 246x? So you go plus 246. So you get 246x minus 246 times 4. 2, 16, 17, 18, 8, 9, 84. So 984, and we're subtracting that. So you have negative, negative, gives me a positive 984 at the end. And to write up our answer with that remainder, we do that kind of rotation. So our end answer, 4x cubed plus 16x squared plus 60x plus 246 plus 984 all over x minus 4. And that would be your answer. Okay, this other stuff, again, it's just the scratch work. Okay. There's an easier way of doing this kind of division, but it's kind of, sometimes it's hard to remember if you don't use it every day. And on top of that, it'll only work if you don't have something in front of that. It only works in cases that look like this. When I'm pointing at the denominator, when the denominator is linear with a coefficient of 1, then you could do this next method, which is synthetic division. Okay. You'll use it later when we do synthetic. You'll use it later when we do factoring problems. Okay, so it's not, it's not just a party trick that you pull out every once in a while. It will have some applications here. So the divisor here must be of the form x minus c. Okay. So the thing you see in the denominator of your fraction must be some x minus c. In this case, c is 4. Secondly, then, you're going to be using the coefficients without the variables. We just write use the coefficients without the variables. Okay, so let's look at 17. We have 2x squared plus x minus 10, and we're dividing it by x minus 2. So how does this work? Well, our c value is 2. We're going to make this little wedge over here and put it there. And then write the coefficients of this guy, 2, 1, negative 10. And leave a little space in this row, and then draw a big line. Okay. And the first step is to drop this 2 down to here. And then go 2 times 2 is 4. Put it here. And from this point on, you're always adding. So 1 plus 4 is 5. And then 2 times 5 is 10. And then negative 10 plus 10 is 0. Okay. So our end answer, this will be degree 1 less than this. So it would be 2x plus 5 as our end answer. So you just get the 2 and the 5 from here. Let's look at 22. I have 5x cubed minus 6x squared plus 3x plus 11 divided by x minus 2. Okay, so same deal. This time the c value is 2. If it was x plus 2, you'd put a negative 2 here. Okay. Across this direction, I have 5, negative 6, 3, and 11. Okay, same game. So you drop down the 5 and then start multiplying. 2 times 5 is 10. 10 minus 6 is 4. 2 times 4 is 8. 8 plus 3 is 11. 2 times 11 is 22. And then 22 plus 11 is 33. So this time we have a remainder of 33. The result of the division then is 5x squared plus 4x plus 11 plus 33 all over x minus 2. Okay, we could do the same stuff with placeholders, right? So synthetic division with placeholders. Okay, so let's take a look at, in this case, at 28. I have x to the 7th plus x to the 5th minus 10x cubed plus 12 all over x plus 2. And right, so the c value this time is negative 2. Okay, so I put negative 2 there. And then you put 1 for x to the 7th, and then 0 for x to the 6th, which is missing, so we need that placeholder. And then 1 for x to the 5th, 0 for x to the 4th, negative 10 for x cubed, 0 for x squared, 0 for x, and then 12. And then once you get it set up, it's just business as usual. Drop down, you get 1. This will be negative 2. This will be negative 2. This will be 4. This will be 5, negative 10, 20, 20, and then finally negative 40, and then negative 80. So our final answer then, this will have 1 degree less than the original, so it's x to the 7th, this will be x to the 6th. So it equals x to the 6th minus 2x to the 5th plus 5x to the 4th minus 10x cubed plus 10x squared plus 20x minus 40 minus 68 all over x plus 2. And that's it. Okay. Now, so those are the mechanics of these guys. Now we get into more theoretical stuff. And the first thing we see is the remainder theorem. So if you have some polynomial f of x divided by x minus c, you could rewrite it as some polynomial plus f evaluated at that point c divided by x minus c. So let's look at number 20. I have 5x squared minus 12x minus 8 divided by x plus 3. So, first note, what is f of negative 3? And this is what we're considering to be f. Okay. This is our f of x. So if you put negative 3 in there, you get 5 times 9 minus 12 times negative 3 minus 8, which is 45 plus 36 minus 8. Okay, so 45 plus 36 is 5, 81. 81 minus 8 is 373. Okay, so what? Well, this 73 is going to be the remainder that you get left over when you do this division. Okay, that's what this theorem is kind of saying. So let's take a look at that. So if I have negative 3 is the divisor, and I take 5 minus 12 minus 8, and then do my division, what I'm going to get is 73 as the remainder. Okay, so drop the 5, get negative 15. So 7 to negative 27. This will be 81. And then 81 minus 8 is, again, 73. Okay? So pretty nifty stuff. The next sort of theorem is the remainder theorem. Okay, so this says if f of c equals 0, then there's really no remainder when you do division, right? So your formula from above will have f of x just over x minus c equals q of x, because f of c would be 0, so it would be plus 0. And then you can multiply both sides by x minus c, and you get f of x equals q of x times x minus c. Okay? So if you get even division, you can factor the function into a product of some q of x times this x minus c part. Okay, so let's take a look at one of these characters, number 2. And we have x squared plus 3x minus 10, and then divided by x minus 2. Okay. So we note what is that, this function evaluated at 2. What is that? So f of 2, and again, this is what we're calling f of x. F of 2 is 4 plus 6 minus 10, which is 0. Okay? So this thing should be evenly divisible by x minus 2. And so at the end of the day, we should be able to rewrite x squared plus 3x minus 10 as x minus 2 times something, that q of x from above. So that's easy. Then it's easy to figure out q of x. You just do long division. So 2 here, and then we have 1, 3, negative 10. Bring down the 1. 2 times 1 is 2. So 5 times 2 is 10, 0. So our q of x is going to be x plus 5. Okay, so this thing here will be x minus 2 times x plus 5. And so what's happening is that you can use synthetic division to factor polynomials, which is kind of, sorry if I lost the page there, which is kind of what we're going to be worrying about next. We're going to be worrying about factoring these guys, and why factor is so you can find the zeros. Once you set this equal to 0, you see the roots are 2 and -5. So that's what we're after. That's the game, and that's really what these theorems are heading us towards. Okay, that'll be it.